All right, hypothesis testing. Let me start with this example, guys. Let's say an oil change place advertise that they guarantee an oil change in less than 10 minutes. That's their advertisement. That's an attractive one. People who are in a hurry, they would love that, and they go. They might charge them a little bit more, but people want to save time. Time is a value to many of us. But how can we verify their claim? They're claiming that an oil change take less than 10 minutes. How they could be right, they could be wrong. What do you think, guys, we can do to check whether their claim is valid or not? Any ideas? Let's do some brainstorming here. What would you do? Any suggestions?
You can just get an oil change and
Okay, you go get an oil change and it takes 8 minutes. But does this mean that this is the case for everybody? Maybe you were the lucky one. They didn't have any cars waiting in line and it happened to be lucky. Or you could have gone there and it took you 12 minutes. Would you say that on average that their time is wrong? It takes more than 10? Probably not. Probably at the moment you went there were so many cars. It was like, a peak time of the day, and it ended up waiting a little bit more. So what do you think, guys? Rather than just doing one customer, what do you think we should try to check on?
The average time for multiple customers?
So we have a sample, exactly. So guys, look what you can do. You go there and you stand there and observe not only one car or two cars, probably 15 or 20 cars. And you observe the wait time for each car. And then you can come back to my class and then I can show you whether their claim is valid or not. So we need a data from a sample. What I'm trying to tell you, we need a sample. The bigger the sample, the better. If they let you wait there, stay there for 3-4 hours, you can record data from so many cars, and then your study will be more reliable than if you were using a small sample. So what we can do, guys, a student will go there, pick up the data, and give us a list for the wait time for, let's say, 20 or 30 cars or 40 cars whatsoever. And then we can find, the sample mean, we can find the sample standard deviation. And based on the information that we get from the data set, we can make a decision whether their claim is valid or their claim is not valid. And if you guys can come up with a decision that their claim is not valid, and you can show them the statistics, you can go after them and tell them that you're putting a false ad, and lying to people just to get the business. So that's how important hypothesis testing is. If you guys, let me ask you a question. So the oil company is claiming that the mean wait time is less than 10 minutes. That's what they're claiming. If you are suspicious and you think their claim is wrong and you want to make a counterclaim, what would be your counterclaim? So we get suspicious about this. We want to make a counterclaim. What would be our counterclaim, guys? It has to be the total opposite of this.
More than 10 minutes?
More than, or what's the total opposite of this?
Greater than?
Greater than or equal to 10. So if that's your claim, that's your counterclaim. And they're totally different from each other. They claim it's less than 10. You claim that it is 10 or more. Then the one that you can support his or her claim will be the winner, prevail. If you cannot support this claim, that means the other claim is the valid one. So if you guys ask, I tell you, I don't have less than $10 in my pocket. What does that mean? I don't have less than $10. That means more or equal to $10 in my pocket. Exactly. I have the opposite when I say not. Okay. Let's say the oil company claims that the mean time to change oil is 10 minutes. You get suspicious and you think their statement is not valid. What would be your counterclaim, guys, here? What's the opposite of equal?
Greater or less than?
Okay, so together, how would you put them together? Let me see. So you said either greater or either less. But how can you put those together? What about, it could be greater, it could be less. How can we put those two statements together? What's the opposite of equal, guys? One statement, let me see. Not equal, yes, Carlene. So this is the claim, this is the counterclaim. Okay, let's do one more. I'd like you to pay attention to those signs here. Okay. Let's say they claim, somebody claimed that they mean, an oil change company, they will never claim that their mean time to change oil is greater than 10, because nobody will go there. When they say our mean time is greater than 10 minutes, who's gonna go there? Because it could be 100 minutes, could be 150. So nobody makes that claim. But let's suppose somebody make a claim about something and they say our mean is greater than 10. And we wanna do a counterclaim. We get suspicious about that and we think this is not correct. So what would be our counter? Who can tell me?
Less than or equal to 10.
Exactly. Okay. I like you guys to know this now. If somebody put greater and you put less than or equal to, these are total opposite statements. They cannot win together. If one win, the other one must fail, because they're total opposite of each other. These two statements are total opposite of each other, guys. If one statement wins, the other one must fail. So if the mean is equal to 10, it can't be not 10, different from 10. That's it. So if this is good, that's the second one is bad. If the first one is good, the second one is bad. If the first one is bad, the second one is good. So because they're total opposite of each other's. And the same thing apply for the first statement. If the first one is good, guys, the second one is not good. If the first one is weak, that means the second one is strong. And what I like out of all this, for the sake of algebra, guys, that you know that these two are the opposite of each other's. And these two are opposite of each other's. And these two are opposite of each other. So anytime someone makes this one as a claim and you want to do counter it, right away you will make that one. And anytime someone makes the first one as a claim, you want to counter it and say it's wrong, you make the second one as your claim. And anytime someone makes this one as their claim and you say that this is wrong, you want to do a counter, you just do that one. And what I would like you guys to just remember them in pairs. This is how they always come. This is the first set, the second set, and the third set. This is the algebra that we need, you know, for chapter 7. This is, we read it, guys, as less than or equal to, a greater than here. This is equal to and different from, and this is a greater than or equal to and less than. Okay, any questions so far? Okay. What is a hypothesis test? Let's give you the definition of a hypothesis test. It's a process that uses a sample statistics that uses information from a sample in order to make conclusion to test a claim about the entire population. For example, an oil change company makes a claim that their mean wait time to do an oil change is less than 10 minutes. In order to study this claim, you need to collect the data from a sample and make conclusion about the population mean. And that's what hypothesis testing is. Let me give you another example here. An automobile manufacturer advertises that its new hybrid car has a mean mileage of 50 miles per gallon. Well, that's what they advertise. In order to test this claim, guys, you need to go and check on some of those cars and see if whether they do 50 miles per gallon, record the data. To test this claim, a sample would be taken. If the sample mean differs enough from advertised mean, probably we can conclude that the company's advertisement is false. But if you come with a sample mean that is like, let's say 49.7 miles per gallon, that's very close to 50. So probably the company's claim is valid. So we're going to learn how to validate a claim or not to validate a claim later, just in this chapter, but just to give you an idea. In general, guys, we don't know what the population mean is. We never know. If you ask me, guys, what's the average salary of a person in the United States? How do I know that? We have over 300 million people. We cannot figure this out, but we can make conclusion. We can make predictions. We can make estimates, just about it. So in general, we don't know the true value of a population parameter. They must be estimated. For example, guys, when they say, just about the Moderna vaccine, that the efficacy is 95%, and they said in general it is 95%, how did they figure this out? It's based on a sample of 20 or 30,000 people who went through trials, just and took the vaccine. So they use a sample to make a conclusion about the population, and they advertise to you that the efficacy is 95%. It doesn't mean that they tested every single one, and every single one in the US got the shot, and that's why 95% of people, just did fine and 5% did it. No, they did it from a sample. So we don't know what the true mean is. We don't know what the true proportion in real life is. Like, for example, if I ask you what proportion of students at Henry Ford College eat breakfast before they go to their school, I don't know. There are 15,000 students, but all I can do is get a sample of 50 students and get some information whether they eat breakfast or not, and use that one to make a conclusion about the entire student proportion. And that's what we're going to be doing in chapter 7. We will use sample data to make to study hypotheses about the entire population. Okay, now statistical hypothesis. When you test a claim about a population parameter, we're going to start with the mean, guys. We will state two hypotheses. One is called the null hypothesis, and one is called the alternative hypothesis. And those two hypotheses are going to be total opposite of each other's. And that's why when I started the lesson, I was showing you the difference, just between the two different signs. So a hypothesis test, when you do a hypothesis, you will start by stating two statements. One, it's going to be called the null hypothesis, and one is going to be called the alternative hypothesis. And the alternative, guys, it's what it says. It's the alternative to the null, so it's going to be the total opposite statements. So hypothesis testing starts with stating two hypotheses. One is called the null, and one is called the alternative hypothesis. The null hypothesis, guys, let me give you the definition. We're going to do some definitions here. Is a statistical hypothesis that contains a statement of equality. So it has to have one of those three signs: less than or equal to, or greater than or equal to. The label of the null hypothesis, it's H0, and it's read H sub 0 or H naught. You don't need to know how to pronounce it, but that's how we write it down. The null hypothesis denoted H0 often represents status quo, previous belief, or no effect. And the null hypothesis contains the signs, as I said, this, or that. Without reading the alternative hypothesis, guys, can you guess what signs are going to be in the alternative? If we have this one in the null hypothesis, what do you think the sign will be in the alternative hypothesis?
Greater,
Yep, very good.
not equal to, and less.
Not equal to and less. Exactly. They come in pairs, guys. If you put this in the null, you must put that in the alternative. If you put equal in the null, you must put that in the alternative. If you put greater than or equal in the null, you must put that in the alternative. So let's read it. It's a statement of inequality. It contains a greater than, different from, or less than. This statement must be true if the null hypothesis is false. So guys, if this guy is false, this one is true. And the other way around as well. We read it as HA. A stands for alternative, guys. It's read H sub A. This hypothesis is assumed to be true when the null hypothesis is false. So if you guys can prove that the null hypothesis is false, automatically you can conclude that HA is true. Both the null and the alternative hypothesis should be stated before any statistical test of significance is conducted. So guys, in this chapter, the first step that you have to learn, and that's what I'm going to spend the time today on, showing you how to state the null and the alternative hypothesis. In other words, you are not supposed to do a data analysis before you state your hypothesis. So anytime, guys, you want to study a case, you have to know what you're studying. What is it that you want to find out about? So you have to state some hypotheses. And then based on those hypotheses, you can do your study. You either can conclude that your study is false or your study is not false at the very end. Okay. So the alternative hypothesis, guys, contains the following signs: greater than, not equal to, and less than. So if you have this one in HO, guys, you must have this one in HA. And if you have this sign in HO, you must have that one in HA. And if you have a greater than or equal, you must have that one. They come in pairs, just like that. Okay, that's how they come. These two together, these two together, and these two together. This is less than or equal to, this is a greater than. Equal, not equal. Greater than or equal to, less than. Okay, here. One hypothesis is called the null hypothesis. And the other one is called the alternative hypothesis. Usually the null hypothesis is, they call it the status quo. It's what people believe in, that's been the practice. And somebody will come and say, no, that's not true. There's something else. I think this is wrong. Then he's talking about the alternative hypothesis. And that's what I said. The null hypothesis, usually they call it the status quo, or the previous belief, or no effect. Okay. And so two statements, null and the alternative hypothesis. Now, the major purpose of hypothesis testing, guys, what is it that we're going to do in this chapter? We're going to state the null and the alternative. And if somebody wants us to support the alternative, we try to collect evidence and see if we can support the alternative. If we cannot support the alternative hypothesis, we're going to say we cannot support it. If we can support it, we're going to say that we have enough evidence to support the alternative hypothesis. And I'm going to give you an example, guys, from the court. And to mimic, just the hypothesis testing idea. Let's someone is being accused of wrongdoing, just a crime. This person is going to go to the court. And they're going to be jury and they're going to be trial. But here are the assumptions of the court. When they try someone, they're not assuming that this person is guilty. Otherwise, there is no need, you know, to try this person. The assumption is the defendant is not guilty. The attorney for the defendant, guys, is going to support this fact that the defendant is not guilty. But if you are the prosecutor, guys, what fact would you be supporting? What fact would you be fighting for if you are the prosecutor for the city? Would you be trying to support that the defendant is not guilty or otherwise? What would be your statement?
The defendant is guilty.
Exactly. This is, guys, called HO, and this is called HA. Do you guys agree with me that those two statements are total opposite of each other? Yes or no? They are. If you're not guilty, that means you are innocent. So they're totally opposite to statements of each other. This statement, the first statement, the attorney for the defendant lawyer is going to try, you know, just to provide evidence for. For the second statement, the prosecutor is going to try to provide evidence for. Who would win, guys? You should know. Who would be the person who win? The person who would do what will win.
Who proves their case?
How? Collect
By
enough
evidence.
Beyond
A reasonable doubt.
Beyond reasonable doubt. If the prosecutor can show enough evidence beyond reasonable doubt that the defendant is guilty, then HA is true and HO is false, so that the defendant will be convicted. If the prosecutor cannot collect enough evidence beyond reasonable doubt to convict the person, then the defendant will be declared not guilty. You notice, guys, in the court of law, they never say that the defendant is innocent. Unfortunately, once someone, you know, just is being tried for a case, you can never prove your innocence in the court of law. They say not guilty, which means probably innocent, but they don't say innocent. So not guilty probably would mean innocent, but it also means that the person could be guilty, but we could not find enough evidence to convict that person. That's why they don't say is innocent. They say is not guilty. So this is an example, guys, of a hypothesis test. There are two hypotheses here. They compete with each other. If you are the prosecutor, guys, then you're gonna try to collect enough evidence to support HA. If you cannot collect enough evidence to support HA, then there is no way that you can say that the defendant is guilty. The jury will have to declare that the defendant is not guilty because you could not show him enough evidence beyond reasonable doubt. And hypothesis testing, guys, works exactly the same way. We state two hypotheses. If we can collect enough evidence to support HA, we say then HA is true. If we cannot collect enough evidence to support HA, we'll say HA is not true. It's going to work very much the same way. Okay, so I thought to link the two, guys, so you can have a connection. So actually now you know that in the court of law, they do hypothesis testing without even noticing. And let me just do some more reading here, guys, before we do some examples on how to state the null and the alternative hypothesis. We will reject HO and support HA if the data provide enough evidence against HO. If we cannot provide enough evidence, guys, that HA is true, then there is no way that you can support HA. Just like in the example of the court, the prosecutor would have to have enough evidence beyond reasonable doubt, remember that word, that HA is true in order to prove his case. And guys, if you go back in time and if you watch TV, you know there are so many cases that people were tried and did not get convicted simply because the prosecutor could not collect enough evidence, although deep inside us, we know those persons were guilty, but the court could not convict them. And there are some people who were wrongfully convicted, just before, because those evidence that we should call beyond reasonable doubt, they were not beyond reasonable doubt, but we couldn't prove otherwise at that time. So it works, just both ways. All right. So there are 3 ways to state the null and the alternative hypothesis, guys, and I'm going to show you those 3 possible ways. Always, the statements come in pairs. Let's say the first section of the chapter 7:1 and 2 and 3, it's all about the mean, testing the mean. So I'm going to put the mean here, the mean. Let's say we're testing if the population mean is against the number 100. I would like one of you guys to give me all the possible inequalities that I could put here. What could I put in HO here? The signs. Let me begin. Less than, remember, HO is the sign of equality. It has to have the equal sign. So if this is less than or equal to, what would that be in HA?
Greater than.
Yep. Okay. Equal. What would it be in HA? Not equal. And let's do the third one, guys. This is how you state your hypotheses. You either use those 2 signs or these 2 signs. Now you ask me, where did I come with the number 100, guys? You will see that it's coming. He's going to give you this number, just like the oil change against 10 minutes. And I just came up with the number 100 just to show you an example. So practice 1, guys. This is where you're going to work with me, please. And I would like you not just to do the math or set up those statements before even I put them in there. Express the following statement using algebraic expressions, equations, or inequalities. Use mu for mean, sigma for standard deviation, and p for proportion. And then write another statement that's opposite to the original. Okay. The mean ID score is less than 120. I'll give you guys a few seconds to write it down, and then I'll write it. Okay, would someone share with us what they wrote? What's the interpretation in simples? What would that be? Mean.
Mean.
Less.
And then the less than sign.
Yeah. Okay, now I want the opposite statement. What's the opposite?
Mean is greater than or equal to 120.
Excellent. Very good. Let's go number 2. A transportation company claims. You guys, you can't emphasize enough how important this first step. That's step number 1 in the hypothesis testing. So after today's lesson, you will have learned 20% of this chapter because there are 5 steps. This is step number 1 that you need to learn. And it's very important because if you state the wrong claim, then you'll be studying the wrong claim. So that's very, very important that you understand that. That's why I'm spending time on this. A transportation company claims that the mean wait time for a pickup is less than 15 minutes. Take a few seconds and write it down, guys. Yep, Carlene. Okay, who would like to say this with me? Mean less than 15. And you guys agree with me that it's going to be exactly the same as above. That's it. Who can tell me whether this one with first statement will fit in the null or the alternative? Would that be the null hypothesis or the alternative hypothesis?
Null.
Alternative.
Not the null, because the null must have less than or equal to, greater than or equal to, or equal to, because it doesn't have any of those signs, so it must be the alternative, and this one will be the null. Usually we put the null first, but here you're just answering the question. So it happened that the second one will be the null and the first one will be the alternative. Standard deviation of test scores is no more than 4.5. What is no more, guys, means? Can someone tell me what no more means as an inequality?
Less than or equal to.
Yep. So sigma is less than or equal to 4.5. I want the opposite now. Who can give me the opposite to it?
Greater than 4.5.
Yep. Very good, guys. And it happened that this statement serves as the null hypothesis, and this one is the alternative. Remember, guys, the null must have one of those signs. The alternative, never change it. These are the signs for the alternative. Next one. A school administrator claims that the proportion of students who score 1300 or more on the SAT is 55%. Proportion, guys, we use the letter P, as you notice here. He says use P for proportion. Okay, what would be the statement here? He claims that the proportion is the 55%. Who's gonna help me? Let me see what we have in the chat. No, it says is 55%. The proportion of people who score 1300 or more
Less than or
is
equal to.
equal, exactly. All I need to worry about is the 55% because that's a percent. This is just about, is talking about people who score 1300 or more. So equal 55%, you can do it 0.55. And what would be the opposite, guys? Yes? Okay, let's see. Not equal, I agree. Very good. Please participate with me. I know this stuff myself, guys. I know it very well. I don't need to review it for me. The mean cost of a new computer is more than $1,200. Okay, who's gonna show us what this one is? Mean is mu. Remember, mean is mu. More than 200,
Greater than
1200. Greater than,
1200.
and let's do the opposite. Okay, what is the opposite to this statement? Do you guys
Less
agree
than
with
or
that?
equal
Question?
to.
Yep. Okay. What do we call the first statement where my finger is pointing at, guys? Null or alternative?
Alternative.
Yep. And this one is the null. Next. You see, guys, I'm putting as many examples. I want to take my time with this step because it's very important that you understand this. The engineer hypothesized that the mean Brinell hardness of all such ductile iron piece is greater than 170. So he says mean, guys, so he put mean. And what would that be? Do you guys agree? It's just the same, more the greater than 170, that's it. And the opposite. Less than or equal to 170. You see this number matches in both. You have to use the same exact number. Next one. A manufacturer claims that the thickness of the spearmint gum it produces is 7.15 1/100th of an inch. Thickness means a mean. It's a number. It's not a proportion. So mu, guys, it's going to be a mu. Okay. What would you put there? Can someone tell me? Is.
The equal sign?
Yeah. So you guys, you're learning the algebra, how to translate exactly. So mu is 7.5. And you guys agree with me the opposite. Mu is not equal to 7.5. All right. This is called the null, and this is called the alternative hypothesis. Oh, there's more. Good.
Is it common that the null, or I mean, that the alternative comes first?
No,
Okay.
but in real life, when you want to make a claim and support it, you should try to put it in the alternative, because the null is the status quo, is the previous belief, and we want to change this belief to something new. But you're going to notice some people make the claim, it turns out to be in the null. Other people make a claim, it turns out to be in the alternative. But most of the time, it should be in the alternative. Proportion of flights that are delayed does not exceed 15%. Do you guys still remember does not exceed? We went through it. So that's the algebra that you need for this chapter. What does not exceed means? What do you guys think?
Equal sign?
They're less than or equal. Yeah, I got somebody. Does not exceed means less than or equal. It could be 15%. That's why. If I tell you don't exceed 10%, that means I'm saying 10% is okay, but don't go over 10%. That's what I'm trying to tell you. So does not exceed, less than or equal to. And it says a proportion, guys. So I don't expect you on a test to put mu here. It's a P. Does not exceed 15%. And opposite, who will write the opposite? Can you write it in the chat for me, guys? For the, okay, I have someone. Let's see, I did it. And make sure to put 15%, guys, or you can do this. 0.15. Okay, one more before we go to practice 2. We claim that the mean nightly hotel price for hotels in South Carolina is no more than $65. What's no more, guys? You need to interpret that first to see what sign would you use for no more? Yeah, I agree. Less than or equal to. So you guys, if you write it, mean, this is the simple. And for opposite, you'll see, guys, why I asked you to do the opposite. So you're going to use it in practice too. Any questions so far? Please ask before I move to the next step. Okay, the next step is not going to be any difference from practice 1, but the thing is, we need to label what statement, whether it is H represents the null hypothesis or the alternative hypothesis. So write the claim as a mathematical sentence, state the null and the alternative hypothesis, and identify which hypothesis represents the claim. A school publicizes that the proportion of its students who are involved in at least one extra curricular activity is 61%. Proportion, guys, can we all agree that it's going to be a P? So you just put a P here. Look how you do it. I'm going to give you even another hint. We're trying to compare the proportion against the number 61%. If you guys want to just get it over with, put the 61% here and 61% there. All we need to decide, guys, is whether we use those combinations. I'm going to write them here. This is the first. This is the second. And that's the third.
It's gonna be HO equal and HA
Yep.
not equal to.
You are correct, because it says is 61%. Now, guys, I want to know where the claim is. A school publicizes that the proportion is 61%. So the claim is in HO or HA?
HO.
Yep. Look how you put it like that. So it happened that this claim happened to be in the null hypothesis. That's the first claim. Any questions, guys, about number one? We're gonna go to next one. Don't worry, we're gonna do more. A car dealership announces that the mean time for an oil change is less than 15 minutes. So look, mean, that's the hint, guys. Put a mean here, put a mean, put 15 here. You want to put minutes, it's fine. And just make a choice, 1, 2, or 3. Which one is it going to be? Less than 15 minutes. Where would the less be, guys? In the null or the alternative?
Is it the second one? And then
Yeah, definitely. Don't attempt to put it in the first one, guys, because he says less and you want to start writing in the first one because the null hypothesis cannot take the less. So it has to be here. And you guys, if you know, if there is a less in the second one, then there must be a greater than or equal in the first one. So this is an example, guys, where I showed you that you don't have to start with the null always. Sometimes you have to put the alternative. And once you put the alternative, you can figure out the null because you know if there is a less in the alternative, then you know this is a greater than or equal to. Where is the claim, guys? Null or the alternative?
The alternative.
Yep. Good. Let's go to the next one. This is 20% of the chapter, guys. Write in the null and the alternative statement and saying where the claim is. Census Bureau data shows that the mean household income in the area served by a shopping mall is $72,500 a year. A market research firm questioned 100 shoppers at the mall to find out whether the mean household income of mall shoppers is higher than that of the general population. So the general population is 72,500. We need to check if it is higher. No, the second one is not always the claim, but because he says in the question, it is, look what he says. A car dealership announces that the mean, because they're saying it's less than 15, we say that that's the claim based on what they say. Okay, guys, so what do we do here? That's HO, that's HA. You put the mean, you put the mean. We're comparing against the number $72,500. Okay. We want to find out, you see, whether the mean income is higher than the 72,500. What would you use? What sign would you use for higher?
For HO, it'll be less than or equal to, and
Yeah.
HA greater than.
Yeah, I would start with HA because it says greater, higher, and then I'll figure out HO. So you guys, you should agree with me. If you know one sign, you should be able to figure out the other one. He's not going to give you both signs in the statement of the problem. He's going to give you one, the claim, and then you have to figure out, you know, where to put it and how to find the other one. He says higher. For me, I knew right away it's a greater. And I know that your instructor told you that the greater than should be always in the alternative. Look, guys, these are the alternative. And these are always the null. Don't mix them up, guys. You mix them up, the entire problem will be wrong because you will be studying the totally wrong claim here. And where is the claim, guys? Yes?
I was just curious for question two, if they reworded it like the name of the car dealership or the dealership or something like it, if it's stating that the dealership themselves announced it, the claim would be the HO, correct?
Oh, no, whatever, whomever, anyone can make the claim. It doesn't matter who does. It's just what's the statement that they're making. Whether you are making the claim or the dealership, it doesn't matter. Whatever it is, just follow the sign. If the sign is one of those three, then the claim is in HA. If the sign turns out to be one of those three, then the claim is in HO. And where is the claim? Do you guys agree with me that the market research claim is in the null, because of the alternative, because they're trying to find out whether it's bigger than 72,500. Okay, I hope that this is making sense to you. Let's do number 4. Last year, your company's service technicians took an average of 1.8 hours to respond to trouble calls from business customers who had purchased service contracts. Do this year's data show a different average response time? Average means mean, guys, so I'm just gonna put the mean. And you guys know we're comparing at 1.8. What would be the signs? Do this year's data show a different average? Last year it was 1.8. This year they want to check if it is different. So what signs do we use, guys?
Is it the
First.
equal and not equal?
Yeah, equal or not equal, guys. And what is the claim? HA or HO?
HA?
Yep. Because it says different, guys. Look. It's not like I'm making this up. I'm just following whatever they say. This is the claim. If you know what you're claiming, guys, at least you know what data you need to collect to support your claim. And the reason why this is very important, guys, because if you put your claim in HO, you'll be studying a totally different claim. I'll ask you to go south, you went north. That's what's wrong with putting the wrong claim here. So you have to be very careful with that. Yeah. Yes. Average means mean, exactly. A manufacturer of tires claims that less than 3% of their tires are defective. Okay, what do we use? Mu, sigma, or proportion, guys? It's a percent. What letter are you going to be using?
P?
P. Okay, you put 3% here. And who's going to come up with the signs for us? Less than 3%. It's not that difficult, guys, to come up with a percentage. Just
HA less than, HO greater than or equal to.
that is correct. That is correct. I agree. And you agree with me that this is where the claim is. It's good to have the claim and the alternative, guys. As I told you, we always try to go against the status quo, and we try to prove that HO is wrong always in favor of HA. But as you notice in some of the problems, guys, not all claims turned out to be in HA. Like the first one, it was in HO. All right. More, guys, because I want you to be good at this. We're going to do some more. A senator running for office again claims that he has the majority of voters. Once you start talking about majority or minority, it's a proportion, guys, percent. That's a hint for you. What does majority mean, guys? You should know that. Well, I think we talked about it earlier in the course.
Is it greater than or equal to?
Greater than what? If you have majority, you have greater than what percentage?
50%?
Yep. And you guys, you should agree with me that's a claim. And you guys can see what this one is going to be. So if I ever ask you guys to study a claim that someone has majority, your claim will be P more than 50%, more than half, over 50%. That's the claim. You see, it turned out to be in the alternative. I intentionally make most of them fall in the alternative because this is where most claims end up to, but it's not always the case, guys. Number 7, the standard deviation of waiting times at a restaurant is 12 minutes. Oh, I'm sorry, I forgot to mention, guys, when you write HO, H has to be capital, and then you put the 0, H capital, then they put a column there. As you notice how I'm doing it. This is how you write it. That's how you write it properly. Standard deviation, guys, it has to be sigma. Okay, and now we need to fill in the blanks. What would that be, guys?
HO equal to 12.
Yeah.
HA equal to or non-equal to 12.
Where is the claim?
HO.
Yep, that is correct. Any questions, guys, so far? All right, great. So this is how you state the null and the alternative hypothesis. This is how the remaining steps, guys, are gonna be. They're gonna be about deciding one thing, whether you reject HO or you fail to reject HO. If you reject HO, guys, that means you're gonna be favoring HA because HO is bad. If you fail to reject HO, that means probably you cannot support HA because you could not reject HO. And let me give you an example on that, guys. Let's say my boss would send me 2 students to interview for a tutoring job. And I interview the first person. And for some reason, I wasn't very convinced, just that with the first person, but I kind of saw some qualities, so I could not reject the first person. She wasn't the top candidate, for the job, but for some reason, I could not reject that person. What does that mean for the second person, guys? I need to hire one only. What would you say?
That they have a greater than chance to.
No, I have to hire one of the 2. I start with the first person. I wasn't 100% convinced, just with that person's qualities, but I could not reject that person. What does that mean for the second person? Will that second person get the job? What do you guys think?
Depends on their qualifications.
What is it?
I said it depends on the second person's qualifications.
No, but when I say I cannot reject the first person, that means
then they get the job if you can't reject.
He gets a job. Then the first person is gonna get the job. The second one is out. But let's give you another scenario, guys, to show you. So if you cannot reject the first person, let's assume the first person is the null hypothesis, guys. If I cannot reject the null hypothesis, that means HA is out. That's it. But now let's do another scenario. I interview the first person. Remember, my boss told me you have to hire one of the 2. One of the 2. I interview the first person. I reject the first person application. What does that mean for the second person? Remember, the first person was rejected.
The second person gets the job.
Do I need to interview the second person?
No.
No, that's it. HO is bad, HA is N, HA is good. That's what I like you guys to try to grasp and comprehend. Once, guys, you can prove that HO is not good, that means HA is automatically good, because those two students were competing with each other. So what I did, guys, as an example, I showed you that the first students played HO and the second one played HA. And that's the scenario that I try to do. So in a hypothesis test, guys, you're going to learn that all the work we're going to do is to decide on one of two things. Either reject the null hypothesis or fail to reject the null hypothesis. That's what we're going to learn how to do that. Okay. And we're going to use data from a sample to make a decision whether to reject the null hypothesis or fail to reject the null hypothesis. Okay. Now, it is possible that we do make errors in statistics because our data is based on a sample. Unless if your data, guys, is based on the entire population, there is always a chance of error. And that's why you have this margin of error in chapter 6. So there is always a chance of making a mistake in when you do hypothesis testing. There are two types of mistakes, guys, that I'm going to give you the definition of those mistakes. A type 1 error occurs when you reject a null hypothesis when it is, can someone complete it? If I reject the null hypothesis when it is what, that would be an error. So someone is telling me 7 plus 7 equals 14 and I tell them you're wrong.
When it's
That's a mistake.
correct.
When it is correct, when it is true. Do you guys agree with me that when you reject something that is true, that you've made a mistake? So if our teacher is telling you x plus x is 2x and you reject this fact, you have made a mistake. That's what we call it a type 1 error, because x plus x is 2x and you are rejecting it. Let me tell you what a type 2 error. When you fail to reject the null hypothesis if I tell you guys x plus x equals 3x and you don't reject me because I'm the teacher, you think I'm correct. You fail to reject, my statement, although my statement is not what? Correct, because x plus x is not a 3x, x plus x is 2x. So you make a type 2 error, guys, when you fail to reject the null hypothesis when it is what? Who can say the word?
Not correct.
Which is what?
False.
False. There you go. So that's type 1 and type 2. In statistics, guys, we try to balance those two type 1, 2 errors. We try to minimize this and minimize that at the same time. But the problem is, if you try to minimize one error, the second one, it's going to go up and vice versa. So it's a balance that you would have to work out in order to minimize both errors. And let me show you this table, guys, and show you what would happen if we make a wrong decision. Let's suppose, guys, the null hypothesis is true and you don't reject it. Do you think that you make a right or wrong decision here? So I'm telling you 7 plus 7 equals 14 and you agree with me. Is this a correct decision or a wrong decision?
Correct.
Yeah, so that's a correct decision. When HO, guys, is true and you don't reject it, you accept it, that means you did the correct thing. That's good. When HO is false, guys, and you don't reject it, you're not rejecting a statement that is false. Did you make a correct decision or a wrong decision? What would you say here?
Wrong.
Wrong decision. What type of error? Is it 1 or 2? You fail to reject HO when it is false.
Type 2.
Type 2, exactly. Let's go to this. HO is true, but you rejected. What kind of mistake did you make here, guys? I
Type
give
one.
you a true statement and you reject it. Well, this is type 1. That's the definition. What about HO is false and you reject something that is false? HO is false and you reject it. You're supposed, guys, to reject anything that is false. So what do you think your decision here?
Correct.
Correct decision. Okay. Before we wrap this up, guys, I'm going to take you to the court case and give you this example quickly and show you that wrong decision would be made sometimes. HO, defendant is not guilty.
Which
HA,
means
defendant
there's
is
something
guilty.
up.
Okay. What's a type 1 error, guys, here in
Oh,
the,
Blocking the screen.
what is it?
Never mind, you fixed it.
Okay, good. All right. Mistakes happen in the court, guys, as well. Let me show you, they can be very serious. What's a type 1 error here? A type 1 error means you reject the null hypothesis when it is true. So the defendant is not guilty and you end up rejecting it. You know what that means as a type 1 error? Means you are putting an innocent person in what? So let's say HO is true and you rejected. That means you did a type 1 error. If HO is true, that means the defendant is not guilty, but we still, the jury, just rejected that fact. That means they end up putting an innocent person in what?
Jail.
In jail. That is a type 1 error, guys, in the court of law. Let me tell you what a type 2 error is. Type 2 error means you fail to reject HO when it is false. So HO is false, meaning the defendant is guilty, but the jury failed to convict that person. What does that mean for the defendant now? He's going to be back on what?
The streets.
Back on the streets. That means you're putting a guilty person back on the streets. Which one, guys, you can live with? Would you rather, in this case, make a type 1 error? If you are to make an error, would you live making a type 1 or type 2? I know the answer myself for me, which one I prefer. In other words, guys, would you rather putting an innocent person in jail or getting a convicted person back on the streets? Which one do you think your conscience, just gonna accept, just more than the other?
The second one.
Definitely. I wouldn't want to put an innocent person in jail, guys. I would rather, if it is a just a guilty person be back on the streets, I would hope that this person, just will straighten out, just his act and his behavior and be a better person. But putting an innocent person in jail is a big deal. Those mistakes do happen in the court, and those mistakes, type 1 and type 2 errors, do happen in statistics as well. But we hope that we will be able to minimize, just those mistakes. So the work always is to minimize the mistakes. So I'm going to stop here, guys.